Assalamualaikum dear students. So today we are going to learn how to find shortest route in a given network. So this is the example you can see on your screen. It has 8 nodes. This is the node 1, which is starting node, and this is the 8th node, which is the destination node. So we have to find a shortest path from node 1 to node 8. So first of all, we have to form this table, which is called distance table, and this actually represents the distances from node I to node J. For example, this is the node 1, and all these distances are from node 1 to the rest of the nodes. From node 1 to node 1, there is no connection, so we can write infinity here, but rather than writing infinity, you can write a large number. So that is why you can see 100 here. From node 1 to node 2, we have a connection, and the distance is 1 unit. And from node 1 to node 3, we also have a connection, and the distance is 2, so you can see 2 here. And similarly, you can fill all these entries of the table. So this is the distance table. So now we need another table for the decision variable. So let me copy this and paste this to have a table for distance variable. So let me delete all these entries so that this can be filled after the solution by the values of the decision variables. So let me highlight this borders, and we can put any color. Okay, so this is the from side, and this is the to side. Okay, so from node 1 to rest of the nodes, similarly from node 2 to rest of the nodes, and from 3 to rest of the nodes. So in order to have an algebraic system for this, we have to write few entries. Like we are going to write total out from node 1, 2, 3, 4, 5, from each of the nodes actually. So how can we calculate this? If we have to find the total out from node 1, we have to sum all these entries in the first row. So let's write formula for this. Sum and sum of all these entries in this row. Enter. And similarly, we can copy this formula by dragging this down. Okay. All right. And total in order to find total in, we have to sum all the entries in the respective column. So let's write the formula again. Sum. Okay. Enter. And to copy the formula, we are just going to drag this. Okay. So next, in order to write right hand side of the equation, algebraic equation, so we have to write total out minus total in from the node. So this will become right hand side of the or left hand side, you may say, left hand side of the equation. So left hand side is out minus in. Okay, so for this we have to of course write the values here. Total out from node 1 and total in to node 1. So total out from node 1 is this. So we have this value minus total in is this. Okay, enter. Similarly, we have to do this for every node. Total out for node 2 minus total in for node 2, enter. And then we are going to do the same for all the nodes. Out for 3 minus in for 3, enter. again equals out for 4 minus in for 4. Okay, and after filling this column, we have equal in between. Oh, and this is the equation, equal sign for equations. Now right hand side is 1 for node 1 and 0 for rest of the nodes until the last node, and for last node it is -1. Okay, so we are almost done, but yes, we have to write the objective function, which is total distance. So let's write this as well. Total distance is equal to sum product of this array from distance table, and the second array is from this decision variables table. And close this and enter this. Okay, so now we have entered all the necessary data. So now we have to solve this, and for this we have to go to data solver, and yes, first of all we have to set this objective function, and this is our objective function. So here is the entry for objective function. We have to minimize the distance for this problem, choose minimum, and now we have to give the range of decision variables, and you can choose these decision variables to fill this. Okay, and yes, and we have to make sure that these variables are binary. Now we have to add constraints. So for the constraints, again, we have to give the cell reference for all these decision variables. If there is a connection, 1 will be written, and if there is no connection, 0 will be written. So that is why these are binary. So choose binary from here, add. Okay, and now we have to add the equations. So for this, this is the left hand side, and this is equal to this is the right hand side, and click OK. So we are almost done, and what we need to do, we have to choose here simplex LP and solve. And here we go. So we have the total distance which is equal to 8. So optimal value of the problem is 8. That is, the shortest distance is 8. And from node 1 to node 3, you can see here, node 3 to node 6. Okay. So 1 to 3 to 6, and then we'll see 6 to 8. So this is the path. 1 to 3 to 6 to 8. And here we go. That is the end of the learning for this lecture. Enter. Okay then, take care. Bye.